high altitude jet aviation now occurs at about 35 to 39,000 feet, which is still pretty safe within the troposphere. Within 10 years, it's going to be 45 to 49,000 feet, which is not still safely within the troposphere. So radiation dosage at those altitudes is a serious concern, especially on the polar latitudes, the further north or south you go. Even now, for polar flights, pilots and crew wear dosimeters to measure radiation. They don't talk about this a lot, but if you're a pregnant woman, you're flying on a polar flight as a crew member and you do it 4 times a month, you're really taking a pretty big risk. There's 3 types of solar storms: radio blackouts, solar radiation, and geomagnetic storms. And the time frame for each of these is listed. There's no way you're going to predict to take any mitigation measures within a half an hour of a radio blackout or a solar radiation storm. Geomagnetic storms, you have about 4 days warning usually. So mitigation, if you have a tinfoil hat, it's probably good. Off topic, but with the state of modern technology, in the last 40 years, we've had really no significant solar events, maybe Halloween 2003. But there's not been enough impetus for anybody to build safety features into anything in the last 40 years. So solar radiation is kind of like a lot of other things. Unless somebody gets killed, we just don't think about it. So now in a modern cockpit, they've got transistors the size of atoms, or 2 or 3 atoms, where 30 years ago, a transistor was as big as my beer belly or my fist. Now you can run a stream of high energy protons through a gigantic transistor, you're not even going to notice. If you run a stream of high energy protons from the sun through a atomic sized transistor, it's going to knock it out. So theoretically, you can take out entire cockpit electronics, or at least several systems, with a solar radiation storm. Hasn't happened yet, nobody cares, we'll see what happens. The geomagnetic storms are what causes energizing of the ground or the ocean floor, where there's transatlantic currents, where there's power grids in Canada. Very fragile system, very open to total failure. I guess you guys probably know that. This is a pretty educated crowd. But one pretty heavy geomagnetic storm can easily knock out the entire country's power grid. It's no big deal. We're nothing compared to the radiation from the sun. And sometimes you listen to people talk about how they're protecting this. It's just arrogance. We have absolutely no ability whatsoever to protect from a major solar radiation storm. Hopefully it's not going to happen. Hasn't killed everybody yet, but it is possible. And again, education is the key to this. It's not being scared. It's not watching crazy YouTube videos about motherships. It's teach these students what it is so they know what they're talking about. So if this does come up, you'll have an educated opinion on it. Space weather impacts in aviation. Radio blackouts have a pretty good effect on aviation communications on the sunlit side of the planet. If you have a big R3 or higher storm, you're going to lose communications, especially in the HF range, with anything on the sunlit side of the planet for several hours. Okay? Solar radiation storms, there's really nothing you can do to prevent it or protect from it because you don't really know what the strength's going to be. Geomagnetic storms, there's a lot of things you can do to help there. Extreme space weather event. One of them in here was pretty good. Let's see, complete loss of GPS satellites. That would be bad. You wouldn't be able to find your way back home. U.S. power grid. Estimated 50% of the U.S. may be under a power blackout. The recovery time may be between dozens of hours to months. Who used electricity today? Who had a satellite-based communication with some other thing on the planet today? Everybody in this room, okay? Imagine waking up without power. No refrigerator, no alarm clock, no Regis and Kathy Lee, no TV, no Real Housewives Tonight, nothing, power. Now some of you in this room can survive that, some of you are outdoorsy. The majority of people in this room would be dead within a couple months without all these things, because we're not equipped anymore to survive this kind of stuff. So a geomagnetic storm is completely capable of doing that. Hopefully it won't, but again, understanding it is the key to all this. Did you know air crews and passengers receive the highest radiation dose of any workers in the country? Most people don't know that when you talk about aviation and piloting and stuff. First thing that comes to your mind is not how much radiation did you get today, but they are the highest exposed workers in the country. I thought that was a pretty interesting fact. In December of this year, we had an event that was pretty strong, an S3 and a G3 storm. I don't know if anybody remembers that. Of course you don't. But we had to stop departures that were going over the poles for several hours because of a solar storm. And you should have seen the reactions. They're like, what are you talking about? A solar storm. But this is the product that's put out to air traffic controllers by NOAA. The official airline use of these scales is anything over a 3 storm of any type, G3, S3, R3. You don't fly anymore over 50 degrees latitude. That's north of 50 degrees. So no Canadian flights, none of that stuff. No flights over Antarctica, clearly. That's the official usage. And I have seen it put into play in 24 years as an air traffic controller and years in the military before that, one time, and that was this year. So we're not very well prepared. Effect on ATC weather. There's no proven direct link between solar activity and extreme weather. But does anyone in here think that the last 2 years have been fairly unusual weather?
Yeah.
We had 11 tornadoes in the state of Georgia in December of last year. I lived in Georgia all my life. We have never had more than, I can never remember having more than 1 tornado in a month. We had 11 in the same night, killed 150 people in the southeast. This is that night. Is it connected to solar activity? I strongly believe that any influence on our atmosphere that swells it, produces heat differences, causing rising, causing different circulation, obviously to me it's going to affect weather. How it does so, I can't explain to you. It seems fairly obvious to me. My opinion is it's related to solar activity. Possible mitigation strategies. This is almost laughable when you read these, but my favorite here. Air traffic control centers have alternate power generation in case of power failure to ensure the safety of air navigation. And the mitigation strategy is go to the backup generator. That's just understand it. Currently, airlines are not flying polar routes when a radiation storm is in progress. What can you do about this? Nothing, really. There's nothing that you're going to be able to do to protect yourself from a massive solar storm, except educate you and your students and your kids and your friends about what it is. Best way to educate them. Get a solar telescope, look through it, study the sun on the internet, and there you go. And solar wind causes pretty auroras too. Anybody here seen the auroras in person? Yeah, they're pretty cool. When I was in the Navy, if you stand inside the aurora, you can't even tell you're in it. You can see it at a distance, but the thickness is so small, it's such a low density that, in my experience, you don't even know they're going on if you're standing right in the middle of it. If you're about 50 miles away looking at it, it's much prettier. So auroras are awesome. That's solar radiation at work. Solar Cycle 24 has had some pretty good events. Steel Hill from NASA sent these videos over to me. You've probably seen most of these on the internet already. There's a nice solar flare. These loops are called coronal loops. They occur in the region of solar flares. That's a pretty decent sized prominence. Greg will probably tell you that's about 30 Earth diameters long. But the SOHO mission is actually at the Lagrange point, L1, between the sun and the Earth. So it's a little closer. But you don't have to be very close again, because it's right around the corner. I mean, it's like we're standing on it already when you think about astronomical terms. So being any closer is not going to be of any benefit once you get outside the atmosphere. And SDO studies the sun at all these different wavelengths just to gather data, because you can see all kinds of different features. You see this surface here that's just boiling? Those are all granules I talked about earlier, coming up, letting out their energy, and falling back down. Post-flare loops. That's a very unusual feature that you can see clearly through any solar telescope, a narrowband solar telescope. Those occur after a massive flare. These particular loops were the delight of the solar astronomy community for several days. Everybody had their own version of it. Comet Lovejoy. The alien mothership that comes in from this direction. Yeah, there it was. You see it? It's funny because this particular SOHO mission is so overexposed to get the corona that any planets in the background, any bright stars, look like alien spaceships. So every time there's some event released by NASA from this particular mission, you get about 20 videos on YouTube. I'm not saying they're wrong, but you get 20 or 30 videos of people saying, the Guru is here, and it's time to greet the aliens, blah blah blah. It's pretty incredible. This comet went that close to the sun and survived and came back around again. Still, did you see that movement right there? They actually adjusted the aim of the SDO probe a little bit to the left to see this comet, and that's pretty cool. You can talk to some guy on the phone who goes, "Yeah, we just moved the SDO." I mean, they actually moved the whole satellite just to catch the edge of that prominence. That's pretty cool. I told him, you know, you can take a telescope and put it on a tripod. It's a lot easier to move it right. Anyway, Comet Lovejoy's about that. We had a big X-flare in July. 10-year-old here, I believe. No, I'm sorry, that's Thomas Ashcraft. He's a pretty good astronomer. He's in his 60s. But that's the same flare that NASA has on their 3D Sun iPhone app. Anybody have the 3D Sun iPhone app? Okay, I'm going to gloat a little bit. You'll see my photos and my buddy Greg's photos on here occasionally. Venus passing in front of the Sun. This is the K absorption. When people say calcium K, what they mean is you're taking a 2.3 roughly angstrom wide bandpass at the K emission line in the calcium spectrum. So calcium K is the K emission line of calcium. Hydrogen alpha is the alpha emission line of hydrogen. And in the hydrogen alpha scopes, it's 0.5 angstroms wide, the bandpass. That's what they mean when they say that. This is a calcium K image of a really nice active region, sunspots, nice clear defined umbra, and Venus passing in front of it. And if that's not cool to you, then you need to check your pulse. The same image, a little while later, you can see the entire event from Hawaii. That's why I've got, you know, I just sat there in awe most of the time going, wow, is this really happening? It was slowly moving the entire time. It never stopped. You could tell it was moving, and it was just awe-inspiring. If anybody has seen this before, they know it's hard to describe unless you see it. Second contact, I believe they call that. We tried to time it and do a measurement between me and one of my club members in Massachusetts. We tried to get all our data together and time it. And we came out with the sun being like 6 million miles wide. So we were off a little bit, but we had a good time. This is a visible light version of the same event. And the two scopes I had strapped to the railings in the earlier slide, all these images were taken through those two scopes, and I just carried them on. You don't need a whole lot. It's just right there. You don't need 16 inches of aperture to see the sun. 3 inches is plenty. Okay? All you need is a decent filter. A little close-up of the same area. Atmosphere of Venus. Again, if this stuff had been around the 1700s, we'd be living on Mars by now, I feel certain. And I hate to keep going back to the same theme, but it's really what I'm all about. In the 70s and 80s, it became all about what's in it for me. And science has kind of taken a backseat to instant gratification and making money. And it's seen, the symptoms of it are seen everywhere in the community. So the whole program is to try to get people interested in this again. Let's get involved in science. Let's go that route in life. Okay? That's what it's all about for me. This video shows this feature right here. Now this is way overexposed, so you can see it. That feature is growing gigantically. This is all in the span of about 10 minutes, and you can see it moving outward. This is the kind of views you see in these solar scopes. Nothing stays the same, but you don't usually get this much motion. But with an H-alpha scope, you can watch it over a couple hours, and things are totally different. Okay, there's where it was about 15 minutes later. You got to remember, this is 875,000 miles in diameter. This is a prominence. Pretty cool, pretty long, you know, exciting. Everybody's happy. Then the clouds came in again. I said, hey, let's switch over to calcium K again and see if we can see anything. You can't get prominences in calcium K, they're just not bright enough. Usually you get nothing. You might get a little smudge. Well, so we put on the calcium K filter. And I said, hey, wow, what's that? This wasn't even visible in H-alpha. Okay? And this is all with the girl or her family now. All going, yeah, cool. The mom and dad got the glasses on, looking at it. Then the filament got a little bigger. This big round circle here is the reflection that you're not supposed to see in the scope. The filament is so long now in calcium K, and it's branched off here all the way to here. This filament is 600,000 miles long. I'm sorry, I keep calling it filament. Prominence, filament, the same thing. This is by far, again, to my knowledge, and I know a little bit about this, the longest prominence I've ever seen anywhere, or recorded by anybody. Okay? And this all happened within a span of about 10 minutes. Those days of, you know, everybody getting apart from each other and staring at their cell phones all day long is just nuts. Okay? It's a community. And it depends on people working together and helping each other do things. So take what you love and go find somebody and share it with them. And I hate to lecture you guys, and I'm not trying to, but it's such a rewarding thing to go out and just give someone something you care about. You'll be amazed at what you'll get in return. The payback is tenfold. Take a little time, take a telescope, whatever, set it up, share it with the community. If anybody wants to get involved in this program, like I say, I'm more than happy to help you any way I can.